Hello and good morning. Today we will be talking about mutually exclusive events. So let's begin by taking some notes. And we're going to begin by introducing some new notation. So let me begin by introducing this U. In probability, this is going to stand for OR. And then we also have an upside down U. And in probability, this is going to stand for AND. I have a couple of examples here, so let's go ahead and translate them using our new notation. So this one reads the probability of red or green. Let's translate this one now. This one reads the probability of pizza and soda. Please familiarize yourselves with this new notation because we're going to be using it quite often throughout this unit. Let's begin now to talk about what exactly are mutually exclusive events, and this has to do with the addition rule that you were exploring in the previous assignment. Venn diagrams provide a great way to visualize which events are mutually exclusive and which events aren't. For example, looking at this diagram right here, we see that there is no intersection. When two events are mutually exclusive, the probability of A and B is going to equal 0. And here we can see that there's no sort of intersection going on here. The events are exclusive from one another. Now, if we wanted to calculate the probability of A or B, we could simply just add the two events together. Probability of A or B would equal the probability of A plus the probability of B. We want this or this. And this is the addition rule for mutually exclusive events. Now let's take a look at events that are not mutually exclusive. The big difference, we can see that right away, is that here we do have an intersection. In this scenario, the probability of A and B is not equal to 0. It's equal to something else. We don't know what it is. That depends on the problem. Now for this problem, if we wanted to calculate the probability of A or B, we have to be a little bit more careful. Here we can get this probability by adding the probability of A plus the probability of B, and then subtracting the intersection, subtracting the probability of A and B. This would be the addition rule for non-mutually exclusive events. The reason we subtract the intersection here is because we don't want to double count. For example, let's say we wanted to calculate the probability of A or B in this scenario. We could do that by first counting everything that's inside of A. But you see here, I already took into account that intersection. So if I wanted to count everything that's inside of B, here you would see that I'm double counting this intersection. So that double count basically gets subtracted here. So for non-mutually exclusive events, we have to subtract the intersection. Alright, now let's use these formulas to proceed with some examples, and then so you can use them in order to finish your assignment.